Hey, welcome back to your favorite technical mathematics class. Let's talk about some simple inequalities here and work some problems. So an inequality is just a mathematical statement that one algebraic expression is greater than, less than, or less than another algebraic. So for example, 3 is less than 10, right? So we got the less than symbol. Then we got the greater than symbol. We got a less than or equal to symbol, so negative 11 is less than or equal to 2. But as stated there, negative 11 is also true that negative 11 is less than or equal to negative 11 because it's only got to be one or the other. It's got to be less than or it's got to be equal to. It's one of the two. So both of these are actually true statements there. Then we get the greater than or equal to sign. Now, all the properties of inequalities are similar to the properties of equality. So if I add something to one side, I got to add it to the other side. If I subtract something from one side, I got to subtract it to the other. If I multiply one side by something, I got to multiply the other side by something. Now, if that's a negative, that means I got to change or flip the sense of the inequality. And let me give you an example. We're usually solving some inequalities. Let me give you an example. Like negative 2x is less than like 8. You know how if we solve this, we're like, well, we got to divide by negative 2. If I do it to this side, I got to do it to this side. Well, anytime you multiply or divide both sides by a negative, okay, both sides by a negative, multiply or divide here, you've got to change this inequality to x is greater than negative 4. So that means all your solutions are all numbers that are greater than negative 4. So like negative 3 should work. Negative 3 should be a solution to this original inequality. Is 6 less than 8? You bet it is, right? But if I had not switched it, if I had not switched this to the other way around, right, from a less than to a greater than, I would have been x is less than negative 4. And now, like, some numbers less than negative 4, like negative 5, for example, is less than negative 4. So that would be an example of a possible solution. Well, if I plug that into the original, 10's not less than 8. That's not true. So that's why you gotta switch it. Anytime you divide both sides by a negative, you gotta switch your inequality. That's called the sense of the inequality. So that's what we gotta keep straight. The other situation where you change the sense of the inequality is like, let's say you finish and you're like, it's right here, 3 is less than x. You gotta have your x on the left hand side. So if you're gonna switch their places, you gotta switch the sense of the inequality as well. So the two scenarios are to get your x on the left. Yeah, switch them all around. And the other scenario is when you're multiplying or dividing both sides by a negative. That's where you got to switch it as well. Okay, so let's try and keep those straight. So number 1 here, x plus 4 is greater than x plus 4, greater than 1. Just subtract 4 from both sides. Well, subtracting 4 from both sides has no issues. X is greater than negative 3. Number 2, x minus 6 is less than 9. Adding 6, no problem. X is less than 15. Number 3, x over 2 is greater than 9. Multiply both sides by 2. I'm multiplying both sides by a positive. That is no issue there. Keep it the same. Number 4, negative 4x. Here's number 4. Negative 4x is greater than 28. Divide by negative 4, divide by negative 4. Ding, 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 we divided by a negative number. I got to switch, right? I switch that inequality, less than there. This is less than negative 7. Otherwise, I'm going to get the wrong solution set. Number 5, 6 minus 2x is less than 20. Subtract 6x first, you got negative 2x is less than 20 minus 6, we got 14. Now divide by negative 2, divide by negative 2. Ding, ding, ding. Divided by a negative, so we got to switch that. X is greater than negative 7 is our solution set on that. I got to erase some of these so I have some room. All right, number 6. 3 minus x less than 1. And let's say, you know what, let's say you took your x over just for kicks here. You got 3 is less than 1 plus x, can't combine those. Now take your number over, 2 is less than x. Remember, x has got to be on the left-hand side. So if you're going to switch these, you got to switch that inequality, right? You got to have x is greater than 2. And that's just proper notation in mathematics. But it also is important because when you go to graph these, if x is greater than 2, you know, all numbers greater than 2, that's pointing, that arrow's pointing which direction it's going. It's pointing to the right. Whereas a lot of the time when students try and graph it straight from here, 2 is less than x, they'll put it on the 2, the open hole on the 2, and then they'll just have it go left. So just be careful on that. Number 7, 6 times x minus 5 greater than or equal to 10 plus x. Distribute that. 6x minus 30 greater than or equal to 10 plus x. Get all your x's on one side, get your numbers on the other. So 5x greater than or equal to 40 divided by 5, and that's a positive 5, so no issues. X is greater than or equal to 8. Finally, the last one, distribute the 3 there. 3 minus 6x greater than or equal to 1 minus 4x. Get all your x's on one side. Let's add that 6x, add that 6x, so we got 3, and subtract the 1 at the same time. So 3 minus 1, 2, greater than or equal to 2x, divided by 2, divided by 2, 1 greater than or equal to x. Remember, we got to have the x on the left-hand side, so we got to switch them. Make sure you switch your sense of the inequality as well. A few more. 2x plus 3 less than 7. Subtract 3 from both sides. 2x is less than 4. Divide by 2 on both sides. And that's a positive 2 that you're dividing to, so no issues with the sense of the inequality. Whereas with negative 4x is greater than 28, when we divide by negative 4, we got to switch that. Third one, 2x minus 5 greater than x. Get all your x's on one side, get all your numbers on the other. So 2x minus a 1x is 1x greater than 5. Fourth one there, distribute the 2, distribute the 4. So we got 10x plus 4 less than 16 plus 12x. Get all your x's on one side, get all your numbers on the other. So we got negative 2x is less than 12. Divide by a negative 2. Uh-oh, ding, ding, ding. Divide by a negative number. Don't forget to switch the sense of the inequality. Last one, we got 4x minus 7 greater than or equal to 2x plus 9. You can get all your x's on one side. What happened? Here we go. Add the 7, add the 7. So we got 2x greater than or equal to 16 divided by 2. X is greater than or equal to 8. Alright, how about an application? Car rents for $30 per day plus, so it's $30 guaranteed, and then 23 cents for every mile, we'll call it M. And we're on a daily budget of $76, so we got to stay within $76 or less, so less than or equal to $76. Well, we go ahead and solve for the mileage, right? How many miles can we drive at most? So let's solve this. We got 0.23 m less than or equal to 46. And we divide by that 0.23, 23 hundredths, 0.23. And that ends up being, so that'd be 200. So m is less than or equal to 200. We can only drive 200 miles or less to stay within budget for an application of inequalities. All right, thanks for listening. See you soon.